Welcome to Pomodoro Joe for Wednesday, July 5th, 2023. Today we're doing LeetCode problem 1493. Longest subarray of ones after deleting one element. This is a medium problem. Given a binary array nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only ones in the resulting array. Return 0 if there is no such subarray. And then we've got some examples. So we have some ones, a 0 and a 1. We remove this 0, so we can have 3, and we return 3. Great. We have 3 ones, a 0, 2 more ones, a 0 and a 1. So if we remove this 0, we'll have 5. And then 1, 1, 1. Oh, and we have to remove 1, so we return 2. All right, so this is an interesting case. All right, this is pretty straightforward. We'll put 25 minutes on the Pomodoro timer, and we will get started. So we'll break this down into pieces. We'll start with our result, and we'll start that with 0, and we'll return the result at the end. All right, so for this, we know we need to go through every single number in our array. So let's start with that. For every n in nums. Now, this is a binary array, so there are only two options for n. It's either a 1 or a 0. So if n is equal to 1, well, for now I'll just pass. Else n is 0. I'll also pass there. Okay, so if n is equal to 1, well, we'll want to keep track of the longest group of ones, or the longest subsection of our array that's all ones. So for this, let's keep a group count. And that'll start at 0. So if n is equal to 1, we'll just increase our group count by 1. All right, so we're keeping track of our current group of ones and how many ones there are. So if n is equal to 1, the group count gets increased by 1. Start at 0, 1, 2, 3, 4, 5. All right, that's pretty straightforward. I think that's all we need to do for the ones. Now, if n is 0, this gets a little bit more complicated. All right, if n is 0, that means that we just came to the end of some group of ones, or we came to the end of some group of zeros. We don't really know which. So at this point, if we have a group count, if we have some ones, and this is the 0 that ends our group of ones, for example, like this 0 here, well, then we'll want to sort of lock in that group count. So this 0 ends some group of ones. Now, this group of ones may be combined with either a future group of ones or a previous group of ones. At this point, we don't really keep track of that, so we might want to keep track of this. Now, we don't know what our future group of ones might be, but we might know what our previous group of ones was. So let's just assume we had some previous group. Now, this group, if we had a 0, we can remove this 0, combine this group count with our previous group count to make one long array of ones, or subarray of ones. So in that case, our option here will be this group count plus our previous group count. Now, we don't have this yet, so we'll have to keep track of this at some point. Let's start it out up here. We have some previous group count. We'll just set it to 0 to start. All right, so if we run into a 0, we can take this current group count, maybe combine it with some previous group count, and that'll be our option for the longest possible array of ones. So at this point, we can set our result. Now that'll be the max of either this option or our current result. So we'll just say this is equal to the option if option is greater than result. Otherwise, we'll just keep our result. Okay, what else do we need to do? So we've reached the end of this group of ones, so our current group count is done because we hit this 0. So at this point, we need to reset our group count. So our group count will be equal to 0. Is that all? Almost, but let's see. We've got this previous group count. Now, we haven't done anything with this yet, but at this point, we are setting our group count to 0. Now, our previous group count will actually be this group, so our future group will be in this group count here. So that means our previous group count will actually be the current group count. It's a little bit confusing, but I think it makes sense. So our previous group count that's going to be our group count. So basically we're taking our current group and we're just going to store it in the previous group count. So our future group count, or this current group count, can be combined with this previous group count when we get the next 0. Okay, so that takes care of that. Now there are a couple of edge cases here that we might want to think about. What happens if we get 2 zeros? So we have a bunch of 1s and then we get 2 zeros in a row. So on the first 0, we'll possibly combine this group count with any previous group of 1s. That will be our result. We'll set our previous group count to hold this group count and reset our group count to 0, so that in our next group, we'll possibly be counting 1s, but if we get another 0, then we'll come in here, our option will just be this group count, and our previous count will have been the previous group, so this will be 0, this will be our previous group, our result will probably be greater, and then we'll set this equal to 0, so our previous group count gets set to 0, and our group count gets reset. So I think we're all right. Yeah, so this handles the case where we have 2 zeros in a row, or 2 or more zeros in a row. So I think we're all set. All right, there are a couple of cases we haven't handled yet. One case is if we get to the very end of our nums. We've counted all our groups, we get to the end. If we don't have a 0 at the end of our group, or at the end of our nums, then we're not doing this section here. We have a group count that we're not actually using. So if we get to the end, we actually kind of need to do this piece one more time. All right, so let's do that out here. We've got to the end of our nums. We actually need to create our option that includes this last group of 1s. Okay. And now the final thing that we're not taking care of, and that's this case here. We didn't keep track of whether or not we actually removed something. We're kind of assuming that we'll find a 0 and that will be removed, or skipped in this case, but we might not get any zeros. And if we don't get any zeros, we still need to remove one of these 1s. For example, this should be 3 if you didn't remove anything, but we output 2 because we still have to remove one element. Oh man, so we'll need one other thing in here. We'll have a removed element. We'll set it to false to begin with. This means we haven't removed anything. Now, if we ever run across a 0, we'll remove that 0. So in this case, we can definitely set a remove equal to true. And then out here, we better check. If we didn't do a remove, then we need to subtract 1 from our result. Then our result equals result minus 1. Now this works because if we didn't remove an element, that must mean that we only had 1s in our input nums. Otherwise, if we ran across any 0, we would have removed that 0. So our result will end up being the entire set of nums, but we'll have to remove 1, so we can just say result minus 1. All right, so I think this should do it. Let's give this a try. All right, that works. Let's submit this and see how we do. And we pass. And we not only pass, we crush it at a 97% for runtime and a 71% for memory. This is an awesome first attempt. All right, there's still a little bit of room for improvement in here, so give it a shot. See if you can improve on this. All right, I think that's it for me. I gotta run, but I hope you had fun. Hope you enjoyed this. Hope you learned something. Hope you can go out and write better code.